like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless. Burning the bridge that keeps us. I'm here and I'm feeling fearless. Exaggerated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear outweighed the person you are. Oh, break out, I've got to see. Spent all my life holding
Test.
all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless.
Check. All right. Hey, everyone. Matthew, we're good? All right. Hi, everyone. My name is Nick Van Woudenberg. I'm the founder and CEO of Rangle, and also I started this meetup almost 5 years ago. We haven't had it in a while. The year got busy, and then we had Elevate Toronto, and we moved offices, but we're all settled in now. So we're rolling out the meetup schedule again at Rangle. So thank you, everyone, for coming to our first Angular meetup of 2018. It's been 4.5 years since the Angular meetup started in Toronto, and it's been a wild time in the industry. So many changes, so many sort of disruptions. There's Angular, JS, Angular, React, Vue. I got to be a fairly kick-ass Angular 1.4 developer, and then I stopped developing, so I'm a little dated, but yeah, I know still enough about Angular, Angular 5, React, and it's amazing. Like it's been really inspirational working in the field and working in this industry over the last 5 years. So today we're going to be talking about Angular in 2018 and some of the cool stuff coming out of the community and what our teams have been working on. Enjoy the presentation, enjoy the beer, enjoy the pizza. It's going to be a great year for Meetup, so I hope to see you back in the following sort of meetups over the next year, as well as some of the other meetups that we're going to be having as well. So thanks, and with no more talk, I'll hand it over.
Testing the mic. Sound good? Awesome. If anyone can hear me, let me know. If anybody's wondering what the Wi-Fi password is, it's Elevate Toronto, one word, lowercase. I'll wait till that comes up too. Sweet. So my name's Hussein Jirde. I started working at Rangle almost exactly a year ago. And today I want to talk about building progressive web applications. We're going to touch up on so everything we do touch up on today can apply to more than just Angular. But I'm going to focus on a few libraries that Angular provides, such as the service worker library and so forth. So before we go into details of what makes up a progressive web application, I want to talk about mobile for a bit. I think it's safe to say that the vast majority of us in this room own a mobile device of some sort. Now, what we do on our mobile devices can vary day to day, but there's no denying that the amount of time we spend on our smartphones and tablets have only increased year after year after year. So according to ComScore, in 2017, the average user spends 16 times more time on popular native apps than they do on the mobile web. So as consumers, there's no denying that we spend a lot more time on native Android and iOS apps than the mobile browser. But funny enough, mobile web pages still received over 2 times more unique monthly visitors than native apps. And this is huge. This just shows we spend a lot of time on the web, even on our phones. So how can we make sure that the users who experience our web pages have a great experience, regardless of what device they use? We can sort of continue building the same apps and web pages like we currently do, but we can think of adding a number of key ingredients up on top. And that essentially is what a progressive web application is. In short, progressive web applications, or PWAs, use modern web capabilities to provide a reliable, engaging, and fast user experience. And the idea is it does this on any device. If we're thinking of adding all these key ingredients or sprinkling different technologies on top, it's probably a good idea of using some sort of tool to measure how well we're doing. One such tool is called Lighthouse, and it's built by the Google Chrome team. You can either install the Node CLI, or use a Chrome extension. I prefer using the extension because it's a lot simpler, and all you need to do is on any web page, actually just pressing the extension icon will run a number of tests on your page. After a few minutes, it'll actually generate a report, and you'll see that in a bit. The report actually gives you a score on how well your page is doing. It'll tell you some things that you failed, as well as things that you're doing well. So it's a nice way to gauge how well you're doing in terms of progressive enhancements. So for the rest of this talk, what I want to do is sort of focus on what Lighthouse, or some of the main things Lighthouse checks for when it tests your web page. And the very first thing that it actually looks for is that if your web page is on a secure network connection. And you can do that by just using HTTPS. So it's important to make sure your web page is secure to prevent man-in-the-middle attacks and so forth. But there's a lot of progressive technologies, such as service workers, which we'll talk about in a bit, that don't work unless your web page is served with HTTPS. Another thing Lighthouse also checks for is, can your website or application work well without an internet connection or with a poor internet connection? I think a lot of us here are quite familiar with seeing the dinosaur from time to time, and we see this when we're using Chrome and we don't have a working network connection. So one thing that we can use in order to prevent us from seeing this is something called service workers. So a service worker is a script that runs in the background of your browser when you view a web page. So how do we add a service worker? We can create the file and write the logic ourselves, or we can use a library to make it easier for us. One such library is called Workbox, and it's also built by the Google Chrome team. You can install the CLI globally, and then you can run a simple generate SW command. And when you do that, what actually happens is that it asks you a couple of simple questions. What is the root of your web app? If you're building an Angular app, you're most likely using a module bundler like Webpack, and you most likely have a final deployed folder location. The next question is, which file types would you like to cache? You can specify if you want to cache all your file types, or be specific in which certain files you only want to cache. The next one is, what should the path of your service worker file live? You most likely want to make sure that that lives in the final folder that gets deployed. And the very last question is, do you want to save these settings into a configurations file? So if you answer yes to the last question, Workbox knows to not ask you these questions again and again if you actually run the generate SW command. It knows to use the answers on that configurations file instead. So as handy as it is to just run a generate SW command and get a service worker up and running in about 30 seconds, the only issue here is that we'll need to make sure we run this command every single time we make a change to our application. For example, if we remove an image, or if we add another file, we want to make sure our service worker is up to date. So another thing you can do is you can actually install it as a dev dependency instead, and you can have the generate SW command as part of your build process. So every time you make a new build, your service worker will always be up to date. So that actually creates the service worker file where we ask it to, but we still need to tell the browser how to register it. And you can do that by adding a script tag in your index.html. The very first thing you can do is check and see if service workers actually exist in your browser, because they're not currently supported in all browsers. And if they are, you want to make sure that you register your service worker after window on load. You don't want the window on load event to contend with service worker registration. You can register your service worker by running navigator service worker register with the location of your service worker file. And if you like, you can have console log output to say it's been successful or something must have failed. So we've talked about how to install a service worker, and we've talked about how to register one, but we really haven't talked about what service workers actually do. So the very first thing you can think about is service workers allow you to pre-cache your application shell. So like the name suggests, your app shell is the shell of your user interface. It's the header, it's the loading icons, it's the footer, it's everything that doesn't hold actual real content. The way service workers work is that they act like a middleman between your browser and the network. When you load a page for the very first time, you could tell your service worker to cache the JavaScript, the HTML, and the CSS that make up your app shell. And when you reload the page for a second time, your service worker can now know to just give those files to the browser rather than having going all the way to the network. So you're getting much faster repeat visits. Another thing service workers also allow us to do is they allow us to pre-cache the results from dynamic content. So we can actually have real data pre-cached, so if the user is using their phone without a network connection, they can see older data rather than no data. So it's the combination of an app shell and dynamic caching that allows for two things: faster repeat visits and the possibility of offline support. So this is a pretty useful tweet that I actually saw recently by Henrik Jorateng, and he was one of the few consultants that worked on the Starbucks PWA that they launched recently. It's still in preview mode, but it's actually a really nice app. And when I saw this, it stood out to me because every time I talk to people in general about offline first and offline support, a lot of the responses I hear are, do I really need to think about offline support? All of my users are going to be having an internet connection. So I think it's more than just offline first. It's reliability. And the idea is if somebody's using your application all the time, chances are they are going to try to use it when they have a poor network connection. They might be on the TTC, they might be on airplane mode, there's a number of different reasons. So Workbox does make it extremely simple to create and register a brand new service worker regardless of what tool or framework you use. But Angular actually has its own library to make it even easier. And it's called Angular Service Worker. So if anybody here has actually tried to build an Angular app, the CLI makes it a lot easier. And it's a command line interface that lets you build an Angular app and not worry about build configurations, as well as scaffolding and everything else is quite easier. So the 1.6 release, which is quite recent, actually allows you to create a brand new app and have service worker functionality baked in by default. So if you want to install a CLI, you can just npm install Angular CLI latest. And when you're generating a brand new app, you can add a -- service worker flag. And what that does is when it generates your final application, and a lot of Angular apps actually have an Angular CLI JSON file that has a number of configurations for your app, there's a service worker flag that's now enabled to true. So the ngserve command is what you can use to actually get a web server up and running. So whenever you're building an Angular app, it's easy to use ngserve to have live reload and see your changes happening in real time. But you can't have service worker changes actually reflected when you use ngserve. You either have to use a separate HTTP server, or you can actually build a production build. So ngbuild creates a final build, and adding a prod flag creates a production build. So with service workers baked in, what happens now is that there are two new files actually created in the final folder. One called ngsw worker, and one called ngsw. ngsw worker is actually that service worker file, while ngsw are the final configurations specified for you to take a look at. What also gets added in your app module, which is the root module of your entire application, is a brand new service worker module that comes from Angular Service Worker. And in the imports, you can see that it actually registers that service worker file, ngsw worker, and it already has it enabled only on production builds. So like I mentioned, Workbox creates a brand new configurations file that allows you to modify settings for your service worker. Similarly, Angular Service Worker lets you do the same thing. There's an ngsw config file that actually exists in your source directory. And here you can actually specify what files you want to cache or how you want them cached. The very first thing you most likely want to specify is where your index.html lives. The next thing is an array of objects called asset groups. These are all the groups, or the groups of assets that define static resources. In other words, here is where you define your application shell. For every asset group, besides giving it a name, you can give it an install mode attribute. Now, install mode tells Angular how you want those files pre-cached. You can specify prefetch, or you can specify lazy. Prefetch is telling Angular, please get these files cached as soon as possible. So even if you're on an initial route, for example, it could be a bundle file, it will automatically cache that file even if it's on another route. And the idea here is you know it's high priority, and if the network connection happens to fail, the user can still see that asset. While lazy is actually more specific to things that you might want to cache only when they're requested. So for example, if you have a number of different images for responsiveness, you probably don't want all of them cached using prefetch. Lazy makes more sense, so only when the user actually does the request, or the browser does the request for that image, the service worker will know to actually cache it. And finally, you also want to specify what actual files you want to cache. So there's a resources object with two separate arrays, one called files and one called version files. The only difference here is files are simple static globs, while version files are actually files that already contain a hash with them. Because this is using Webpack, bundle CSS, bundle.js, and all the chunks actually out there all have hashes. So another thing, like I mentioned, is, again, dynamic caching is also something that you can make sure service workers allow you to do. And you can do that in the same file by defining a data groups array. You can cache your dynamic resources by defining your URLs, or all the URLs you actually want to make sure that it actually gets cached, as well as you have more fine-grained control by defining a cache config object. Max size defines the maximum number of entries you want cached. Max age is how long you want the results of this dynamic resource cached. Timeout is if you want to add a timeout. And there's also a network strategy attribute. The two values there is either freshness or performance. I love the term freshness. I love that they actually chose that as part of their API. But the way it works is freshness is a network-first strategy. Every time your service worker actually hits this specific dynamic resource, your service worker will know to always update its results, its cached results, with the latest data. So if your service worker if your network happens to fail, you get to see the latest data that your service worker cached. Performance works in the opposite way. It's a cache-first strategy. With performance, your service worker is always going to give its results, but if your service worker fails, then rely on the network. You most likely only want to use a performance strategy if you know the data for your app probably won't change in the future. Another very nice thing that Angular actually provides, an Angular service worker, is it allows you to check for service worker updates. And the reason why this is important is if you consider the scenario where you're building an application, you have a service worker and you deploy it, and users who are using your application right now have a service worker on their browser actually serving cache resources. Now, if you make an update to your application on the server side and deploy that, users don't see your change. So the nice thing about Angular Service Worker is that it actually gives you an SW update class that you can actually use and subscribe to check for service worker updates. Once you import that, you can easily just say there's an available operator that you can subscribe to, and whenever that actually fires, you can do something or do anything with a service worker update. A good example is if you happen to be using Angular Material, there's a nice little snack bar UI element that you can use that shows a little tooltip-looking thing that pops up at the bottom of your screen. And the nice thing about, for example, if you're using this, you can easily show that snack bar with a message that says new update available. Do you want to reload with a button that says reload? And whenever the user actually presses that or on that action, you can actually reload your entire window. Another very useful thing that service workers also allow you to do is they allow you to deal with push notifications. Angular also has a class for it, and it's called SW-push. So can we use service workers right now? Fortunately, Chrome, Firefox, and Opera all support service workers. And if I'm not mistaken, I think it was 2 weeks ago, Edge and Safari both announced on the same day that they're currently supporting it in preview mode. And that's amazing, because we know eventually, or pretty soon actually, it can be supported in all major browsers. So another thing Lighthouse also checks for, which is quite important, is if the page load of your application or your web page is actually quite fast. Now, the thing about cutting down page load times is that there's no one right way of doing it. A lot of people have different techniques and a lot of different ways to make sure that their app loads as fast as possible. And I'll just go over a few that you can consider. The very first one that you can think about is something called link preload and link prefetch. So these are simple link HTML tags or link HTTP headers that you can include in your application, and they allow you to actually define specific resources that you want to tell the browser to prioritize. So if you're using prefetch, you're telling the browser, hey, please prioritize this resource as much as possible and download it as soon as you can. Now, you're not going to get the most bang for your buck if you're using prefetch for resources already defined at the head of your HTML. You'd probably get bigger gains if you use it for something the browser might notice a little later. For example, a CSS or font file tucked deep in one of your CSS files. Preload works in about the same way, but it's for resources at a different navigation route. So if you add a link preload header to your HTML, you can tell the browser, hey, this is important. please try to prioritize this as soon as you can, but it's not as important as the resources needed for the current route. So the browser will try to download it only when it takes care of other critical resources. Another thing you can also think about is something called H2 push. So HTTP2 aims to provide a number of performance improvements over HTTP1. But there's one specific one called server push. And the idea behind server push is that you can define or you can set a number of resources and tell the server to give those resources to your browser before the browser even makes the request for them. So you can get very fast first page loads. However, a lot of people have noticed that it's still an experimental technology, and using H2 push for all of your assets, let's say all of your JavaScript files or all of your CSS files, it actually causes a performance hit. So it's something that you might want to try carefully, but it's still something you can't rely on fully just yet. But another thing you can actually think about when you're building Angular applications is something called code splitting. And the idea behind code splitting is instead of giving the user the entire bundle on the initial route, why not give them what they need incrementally as they make it through the other parts of the application? So someone was nice enough to actually get the final output bundle sizes for a number of different JavaScript frameworks and libraries for just simple hello world applications. And some actually had 4 kilobyte output sizes, and others went all the way up to 200. Now, there's a number of different reasons why different frameworks and different libraries actually have much larger or much smaller bundle sizes at the very beginning, but it's something to think about as you're building your application. I think a lot of us here who build front-end apps with Angular or with anything else is that we're making things a lot more client-side heavy, and that comes at a cost of larger bundle sizes. So again, the concept of code splitting your routes only when the user actually navigates to their specific actual pages is called lazy loading. With Angular, lazy loading is actually built into its routing framework. When you're defining your routes, you can define their path as well as the components that make that route, but you can also add a load children attribute to specify a specific module to only load for that route. So for example, here, if I had this in my application, Angular would know to not actually load the details module until the user makes it to the details route. So another thing Lighthouse also checks for is, can your website or your web application be installed on your mobile home screen? And you could do that by adding a web app manifest. So the way that works is you can add a simple link tag to your HTML and define rel manifest and define the file location for that manifest file. And the way the manifest file looks like is it's just a simple JSON. You define a name, you define short name, you define a number of icons with different images for different device screens. For example, an Android tablet's going to need a different home icon than, for example, a small smartphone. And you define theme colors, background colors, display, and orientation. And the way it works is browsers that actually support a web app manifest, what they'll do is when the user actually navigates to the website in a number of different times within a specific window. So I think with Chrome right now, the user has to actually open the page twice within 5 or 10 minutes. What pops up is an actual install banner. And that banner says, hey, do you want to add this to your home screen? And the reason why this is handy is because a lot of us are not thinking about installing websites into our home screen. So this is sort of a prompt to tell the user that, hey, you can actually install this and add this to your home screen, why not give it a shot? And when you do, what you see is a simple icon on your home page that actually looks like any other app. You can't tell whether this is a web app or a native app at this point. Actually pressing the icon will load a splash screen while your JavaScript bundle is actually loading. And when your app is actually loaded, you get a full screen experience. You don't get that URL bar up top, you don't get the back icon, the front icon, you get more of a native app feeling. So can we use web app manifests? Currently, only Chrome and Opera support web app manifests. Edge and Firefox are both currently developing for it. So Safari on iOS, I think a lot of us here probably own iPhones. I own an iPhone. You can always install any web page on your home screen, but there's not much more to it. But what you can actually do is that iOS actually supports some meta tags as well as link rel Apple Touch icon tags, where you could define that you only want to see the little status bar without a URL bar. You can even define the color of your status bar. And when you define your icons, you get somewhat of a similar experience. You see the icon on the home screen. You can actually press it, and you get a full screen experience. Keep in mind, this is Safari on iOS, and service workers aren't supported. So you're not going to get offline support when you're actually using this right now. But you can at least get a full screen experience on any page. So again, the idea behind progressive web is that it's not one specific tool or technology. It's a number of different techniques you can apply to your page in order to make sure your app or your website loads as fast and as reliably as possible. I think there are two important metrics that need to be sort of explained and thought about when you're thinking of progressive enhancements. And they do relate to page load times. One being first meaningful paint. And that's the time it takes for the user to see actual meaningful content when they load the app for the first time. Time to interactive is when the JavaScript thread settles and your user can actually navigate and use your application. Now, I see a lot of different statistics for time to interactive with mobile phones like a Moto G4 and on throttled 3G or emerging market connections. And the reason why people use those throttle conditions is because we've all become accustomed to building our applications on powerful MacBooks and powerful desktop machines. We don't think about how our application loads on a poorer device with a weaker network connection. So one statistic that I saw recently said that time to interactive on average for mobile phones on poorer conditions is 16 seconds. I saw another one that says 19 seconds. And the more numbers I see, the crazier it gets. I think one thing to think about is if your application takes longer than 5 seconds to load, a lot of your users will probably give up. It's another super useful tweet that I actually saw quite recently, and when I saw this, it kind of spoke out to me. And the thing is, when I talk about progressive web applications to people in general, I think the most people who are excited about it are developers. There are people who are actually building the application themselves. But I've yet to meet many people who don't actually do development who are excited by the idea of installing apps to their home screen or getting an offline experience on a web app. And I think it's something to think about as things are improving in the landscape. The only opinion of PWAs that people I think should be more interested in are people who don't know what a PWA is. Another thing I do want to talk about is whenever I do mention progressive web applications, there are a lot of similarities to native apps, right? And I think a lot of the good things in native apps are coming to the web, but they're not the same thing. I think a lot of people will eventually ask and they'll say, hey, will progressive web apps eventually replace native apps? Can they be used as a replacement to native iOS and Android apps? And I think it's not a fair judgment. It's sort of comparing apples to potatoes. It just doesn't make sense. They're two completely different things. The idea about progressive web apps is why not continue building the apps you currently build, but just adding these newer technologies on top. And this is an expression that I sort of think about when people say progressive web apps will eventually replace native apps. My name is Hussein Jirde. I hope you guys enjoyed this talk as much as I enjoyed giving it. You can reach out to me anytime. I'll be here for a bit to answer questions as well. Thank you.
This is not forever. Folks changing like the weather. Cold wind and all around. Toxic people being severed, like leaves falling in September. Cold wind and on the ground. You can cut me go.
sorry about that. I have a hard toggle. Anyway, welcome back to the second part of our Angular meetup. So thank you, Hussein, for presenting earlier. That was wonderful. Progressive web apps. We're going to go in a slightly different direction today. This will be a little less useful probably than progressive web apps are, but not completely useless depending on your class of application. So right now we're going to do a little bit of zoning out. And I realized after I pitched the title for this talk that zoning out is kind of negative. So I actually looked up the definition, as one does, and apparently it's to fall asleep or lose concentration or consciousness. And when we thought about the title about a month back or whenever this whole thing came around, I was thinking, I'm zoning out! It was more of like a hype thing. So I'd like to just update this definition a bit and use what I think is a slightly better definition. I'm zoning out, but a wildly rational reaction or spell of behavior. So slightly modified things a bit. Probably doesn't work in real life, but we're going to do it anyway. So jokes aside, what actually is Zone.js? How many folks here in the room know what Zone.js is? Okay, so we've got like 70 odd people, and I think like 5 put their hands up, which is good because we're not going to get too deep into technical mumbo jumbo. We're going to try and keep it to what you would actually need to know to be successful with Angular and Zone.js in the new Angular 5. So this is probably what a lot of you know of Zone.js. This is big stack trace dump. And it's not necessarily sort of Zone putting its best foot forward. Zone.js is actually really, really cool. It's just not good with introductions. And this is probably the introduction most of us had to Zone. We're like, what is this? I know I made a mistake, but come on, what am I doing with this? And let's just forget about these crazy stack traces for a minute and just talk about what Zone is. And then we'll talk about how we can use it with Angular or how Angular uses it. And then we're going to zone out a little bit after that. So Zone.js is a library that helps us manage asynchronous JavaScript code. And I think at this point, everybody's probably heard that like 70 times before with promises or RxJS or callbacks, I don't know, you name it. But this is a bit different. This isn't the implementation details of asynchronous JavaScript code. This is more lower level. This is like us getting to know what's going on with our asynchronous code a little bit more. It's kind of like notifications. And it's a first-class feature in the Dart programming language, which probably, has anybody here programmed in Dart much at all? So nobody at all. Anyway, Dart is a language Google championed several years ago to do some web stuff. Compiles to JavaScript, does a bunch of stuff. But one of the features that the Angular team really liked about Dart seemed to be its zone usage. And they liked it so much that it's become a stage 0 proposal to the ECMA TC39, which is the European Computer Manufacturers Association Technical Committee number 39, which sounds like a mouthful. They're just the people who make up the rules for how people make JavaScript. And there's a long and storied history about that, but it's not really relevant to helping us. So how does all of this zone stuff really help us? And like I said, kind of unfortunate for this conversation, it doesn't obviously help us very much, but it does in all sorts of different ways. And specific to Angular, as this is an Angular meetup, Zone helps us in a number of ways. So as we all may or may not know, JavaScript is an execute to complete language. We write some code, the interpreter comes along, or the JIT says, hey, here's some code, I'm gonna run this, and then that, and so on and so forth until there's no more code to run, and then things sit in basically a message queue waiting for some event or something to happen. We'll talk about that a little bit more. The reason this is important for frameworks, specifically things like Angular, is that if JavaScript runs executes all of its code till it completes, and everything else is more or less asynchronous, then all updates to our DOM, they all have to happen either at the very first moment when a script is run, or later on when some sort of event queue or asynchronous thing happens. And this is where Zone comes in. It basically takes the Angular 1.x magic that they did with $scope and $digest, and it makes it even more seamless. So it's just automatically there in the background. And what exactly is this going to look like? Well, I've got sort of picture of my mental model of it here. And this picture is a bit rough, like actual browser implementations are not going to look this simple. There's a lot more going on under the hood. But this is kind of how I like to think about it. So we've got, the newest things that have happened in the sequence of our program at the top and the oldest things at the bottom, so time is moving downwards. And we've essentially got an event queue over on the far side over there, where events are put into later. So we can imagine any web-based JavaScript program is going to start by loading a script. The script is going to load any assignments, immediate invocations, or other executions. They're all going to happen. Now, in this particular sequence of events, I've imagined that right up there at the start, when our script loads, there's a set timeout that is registered essentially as an event handler through a set timeout call for 250 milliseconds. Not pictured there is an add event listener, which we'll get to later. So basically our script loads, says, hey, I'm gonna set a timeout. You're gonna run a callback 250 milliseconds odd later. I'm sure most people here are at least roughly familiar with set timeout. Has anybody here not used set timeout before? All right, that's really good. Everybody is at least familiar with set timeout. So a lot of times we talk about asynchronous JavaScript and people are like, what, timeout? You can do that? And it's really new, but I'm glad it's not. So we can set a timeout. We'll idle for 250 milliseconds after all of our script starts. And then eventually that 250 milliseconds passes and our stuff gets invoked. Hooray! And then we idle again, and eventually maybe the user comes along and clicks in our program. And that triggers this invocation of a click handler down here at the bottom, idles. This should hopefully be old hat for everybody here, as more or less what we do with JavaScript. So where Zone looks in this sort of picture, this sort of half-baked mental model, Zone kind of looks like this. So we've got the same thing going on as before. We've got a set timeout happening, 250 milliseconds in the future. We've also registered that click handler for later. The main difference between the previous slide and this one is that here, when the 250 milliseconds is up and the callback happens, it calls out to Zone instead of our code first. It says, hey, Zone, do this stuff. And then our code actually gets run by Zone. And then again, our app will idle after our stuff runs, and then somebody comes along, clicks in our app, and then boom, the Zone.js on invoke intercept happens again, and it handles our click handler. App goes back to idling, and we're back to basics again. So what Zone really does is it lets us sort of tap into what's going on with asynchronous code in our software. And for the vast majority of us, this is largely irrelevant. It's just nice that it works out of the box with Angular. But if you're ever making a framework or doing other library code where you wanted to take advantage of crazy asynchronous things, Zone.js is a wonderful library, possibly a wonderful language extension. So actually, before I talk about how Angular uses it, I'm going to slide over to some code here. And let's look at the most basic sort of invocation of some Zone stuff. This is Node.js code. Can everybody see this at the back? Just put your hand up if it's one more up. OK, so we're going to just zoom in, touch more. And what I've got here is sort of this the most basic thing you can do with Zone.js. There's no Angular involved, because again, Zone.js is a library that Google's essentially polyfilling as some sort of future spec for the browser. So this isn't essential or really baked into Angular. Angular does use some of this kind of stuff under the hood, but not sort of what you're going to see in your normal Angular app. Oh, we've got a question. I'm missing a closing brace on line 11. And it's true, I am missing a closing brace on line 11. That, or it's possibly off screen. Oh, and because I zoomed in too far, it's off screen. So I'm really glad that people are paying attention, because I have been known to make those kind of mistakes before. So let's just pop a new line in there. If I had prettier JS, then this wouldn't be a problem, but I don't have, and now my comma's all missing. All right, now I'm comma flustered. Thanks very much for that. But so we got our super basic example here. We require in Zone.js, because this is just a simple Node app. Yes, you can use Zone.js in Node. It's kind of essential for server-side rendering in Angular. Console log out, hey, we're the root zone, whatever that means. We'll talk about that in a minute. Then we do this crazy zone forking thing, and we just pass it in a name, and then we run a set timeout saying, hi, I'm timeout. And what this looks like if we actually ran the app is something like, oh yeah, my hands are just like, no, you're not typing today. There we go. It says, hello, I am the root zone, and then I don't know if you noticed the delay there, but there's a slight pause, and then it says, hi, I'm timeout. That's that 750 milliseconds over there. So not very exciting out of the box. We've really done nothing other than call it timeout. Then that's because what we've done with this zone.root business here is we've made our own zone. This is an execution context, a place where we can run scripts till they complete executing and then do stuff with them. Really, lines 10 to 13 is us doing that stuff. And Zone doesn't really care about what's in our timeout until it actually gets around to running it. When it gets around to running it, we've told it to do nothing with it, so it does nothing. It just gets out of the way. And this is your normal Angular app. Zone.js is there, and you don't even know, or you don't have to know. So let's do something slightly more interesting with it. Let's try and intercept our set timeout. I'm just going to comment that code out and then scroll down using my super high-tech system here and look at a slightly more complicated example here. So now we've done this whole zone forking business where we've made our own zone, sort of the first step in any kind of zone thing you're doing. And again, we can dive back into that in what forking means in the Q&A. It's not super relevant to knowing the basics of it. What we're doing here, though, is we're providing this fork and saying, hey, when any asynchronous thing gets invoked, let's log out intercept. So let's run that now. Let's see what happens if we run this slightly more sophisticated example. Well, it says hello intercept, and our hi, I'm timeout, even though it's been seconds now, has not run. This is not quite overly useful. And I think part of the problem is here we haven't bothered to read the documentation or really look at how we should use Zone.js or anything like that. It's a little bit more complicated. The one downside is because Zone.js is sort of this low-level framework, I'm just going to escape out of my presentation here. It's a low-level framework, and it's, there's the proposal script here, stage 0 proposal. But what I wanted to see is this is the documentation right now, I'm scrolling really, really fast just to get to the top. But the documentation for Zone.js at the time of this talk is essentially a TypeScript definition file. So if you want to go use this, you kind of have to fool around with what's going on under the hood. And let's just quickly hop down to our onInvoke, which is the one thing we were kind of looking at there. And yeah, it's mostly documentation, but this is sort of the function signature for our onInvoke. It goes way off onto the other side of the screen. Does lots of things, but what we really need to pay attention to in this, if we were reverse engineering it, is this delegate. Actually, I'm in the wrong thing. I'm on onInvoke. OnInvoke only happens when you call zone.run. So we slip back over to our example here. Zone.run kicks off basically the body of our program. Every Angular app is run in one of these zone.runs. We just don't see it happen. When zone.run gets called, that triggers their onInvoke. If I actually flip back to their docs for a second here, and by docs I mean this, we want onInvoke task. And what that's going to do is every time somebody calls, say, a set timeout, or a next tick, or request animation frame, or one of those sort of asynchronous functions that we rely on for all sorts of things, then this onInvoke task method is going to get called. And that looks like, scrolling down, commenting things out. That looks kind of like this, where we've got a little bit more code now just because I've put in a timer, but essentially we say, hey, parent delegate zone, fancy talk, whatever that means, invoke this task. It's the target, and all this stuff came in from our onInvoke callback, so we didn't have to do anything here. Basically what we're doing is saying, hey, the job is done and it took this long to run. So we're doing some really rudimentary and not production-worthy metering, essentially. If we run this code, and again, you notice there's the pause. Hello, I am the root zone. Hi, I am timeout. It has run the timeout now, but we've got hooks. We know when it started the timeout, when it finished the timeout. And the reason this is cool, I know we've gone pretty deep down the rabbit hole here, but the reason this is kind of cool is that if you're making a framework like Angular, you might want to know when these asynchronous things happen, because if you know when they happen, you can reason better about when to make updates to the renderer and how to make a more efficient shadow DOM or whatever it is you're using to abstract away what's really going on under the hood, which is more or less a whole lot of append childs or whatever the low-level DOM routines that are actually getting called is. And this is sort of the magic behind that automatic change detection in Angular. And I'm going to dive sort of out of the weeds here and go back to our slides, because that's more or less what Zone.js looks like. And Again, unless you're really implementing something low level, you probably aren't going to have to dive into this too much. But it is nice to know how it works under the hood, because there's a few cases in Angular where we're going to want to know about Zone.js. And this is the more pragmatic portion of this talk. It's just talking about where this actually is going to affect all of you and your apps. So right out of the gate, Zone.js is largely transparent. We don't need to think too much about it. We don't need to invoke it, instantiate it. In fact, in any sort of Angular app out of the box, it's built into the polyfills sort of file, and we'll take a look at that in a minute, but you don't need to think about it at all. Now, that said, there are, and I've seen this in a number of real-world apps, there are cases where you do need to think about zones sometimes. And the most common need is to occasionally run some code outside of Angular. And this is sort of like back in the Angular 1 days where you could run stuff outside of the $apply, and then you'd end up doing like a $scope.$apply or whatever to make it all work inside Angular. Well, sometimes in Angular, you're going to want to run things outside of Angular. And the two most common cases I've seen for this in the real world have been mouse movement events and window scroll events. So if anybody here has ever programmed mouse movement events before, you probably know that the browser really doesn't throttle or debounce those at all. If you listen to your mouse move and you move your mouse around, we're going to get thousands of events per second potentially, and that can be a whole lot. So if each one of those events happens and you're doing like 1,000 per second, then Angular's got to run its whole change detector over everything every single time. And that can be bad. Like, what if you're doing a tooltip thing and you need to hover over some sort of thing, and maybe you got like 30 tooltips on your page and you're hovering all over the place and they're all listening to different mouse movement events and freaking out and you can't do stuff? Well, there are built-in mechanisms in Angular that don't require a low level of knowledge of Zone. They're documented in the Angular docs. We can take a peek at them shortly, but they let you run code outside of Zone. So that's probably the most common place you'll get to know Zone. However, since Angular 5 came out 2 or 3 months back in October, they have added a feature that lets us optionally disable Zone. And that leads us to the sort of next question is, zoning out. And actually, before we zone out, we'll zone out. Let's zone out. I'm zoning out. I'm ready for this. Let's switch back over to our editor, close this little JavaScript file, and re-enter the world of TypeScript and Angular. So this app here is your stock Angular CLI app. It might not be quite as up to date as the stuff Hussein was using, as I generated this about a month or so ago. So it might be out of date, but it is close to stock. I don't think they've changed this too much. And we don't have very much going on in our app. We've got our app component, and really that's it. There's no services, there's nothing fancy. There is a little bit of stuff we'll look at in the Bootstrapper in a second that will definitely be of interest for zoning out. But otherwise, we don't need to think about this too much. So let's peek in our app component. I'll just close that down. Or really, we've got a little bit more space. We can run all of this here. What I got here is a really simple app component, but it's going to kind of demonstrate what it looks like when you're running Zone and what it looks like when you're not running Zone and what kind of comes into your Angular app while all that's going on. So, start of the class here, we've got a change detector count. We'll set it to 0. We have an animation frames count. We're going to listen to 2 different asynchronous actions and record how often they happen. One with Zone, one without. A little toggle to see if we're animating. And this sort of did.cd function is the one we're going to look at first. And what it does is it increments our change detector count, logs some stuff out, and then returns a string. So there's really not too much going on there. And let's peek at its HTML template and see what's happening in that case. So we've got, 3 possible buttons, but 2 of them are toggling, and a little bit of output. Not too much to this app. Let's give it a run. And I think I left this in a state where, we'll see. This is going to be surprising. Is it going to run with Zone or without? And I'm thinking it's running without Zone. While we're waiting for it to build, let's take a peek. So I've got my app, not app component. Sorry, we're going to look way up in our main file. Where you get to tell Angular the fun stuff about Zone.js is right here when you do your bootstrapping. So what we've done is nothing. We've commented out this bit that we're going to uncomment in a second and see what it looks like that way. So right now we're running essentially a stock Angular app that just has that component we looked at. Let's see what this looks like in the browser. All right, so, oh, good. I have a tab open. That's great. We'll just zoom things in a little bit so we can see what's going on. So there's really not too much going on here. It's just going to log out when it's doing its change detection. I'm going to refresh it. So our dev tools are out, and we'll see what comes out of the box. Now, the console is open on the right-hand side because I needed a place to log change detection. And I could log change detection in the DOM, but if I were to do that, Angular is going to come along and say, hey, wait a minute, you just changed all the stuff that we just detected changes in, and now you're changing it again. So I didn't want to get into that circular loop there. So we've put everything out on the console just so that we can keep the change detector isolated and in doing its own thing. And you'll see right out of the gate, we haven't clicked anything. We haven't run anything other than just loading our app. And the change detector count is up to 4 at the bottom there. It's run 4 separate times. I'm actually going to flip to the code because I think I might have made a mistake in the, oh, I need that app component open to show you if I've made a mistake or not. And nope, got the heck of a ringtone. Anyhow, so we've got detect changes commented out and commented out. So that's just 4 Zone.js changes. 4 different things have happened that Angular has said, oh, something might have changed. We're going to redraw your app. And you know what? Like 9.5, probably even 9. Pick a higher number out of 10 times. None of this is really going to significantly slow down your app. Unless you're writing something high performance, and I mean super high performance, this 4 change detectors here is it's not really going to mess with you. If we click mutate, and all our mutate button is going to do is just update something in the DOM here. Adds a little bit of random string at the top there. You'll notice we've shot up 2 more change detection events. One, I think because we're running in dev mode, Angular does a second change detection round to double check that it hasn't messed itself up in the middle. But we got 2 more. If we click mutate, there's 2 more again. But if we were to start animating something by using request animation frame, which is a bit more aggressive than mutating reactively, we get a whole lot of change detection happening all of the time. And there are a lot of classes of application that do depend on these kinds of things running. So let's just stop that animating. In the last couple seconds there, we ran up 1,062 change detectors firing, and that is probably going to be bad for business if we're trying to run something that's trying to animate at 60 frames a second, especially as our app grows. That's going to be a lot of CD that's running. So what we can do is we can come back to our Angular app, somewhere over here. Oh, VS Code. One day I'll learn to use VS Code properly. I'll reopen that main file again and double click it this time so it stays pinned. And what I'm going to do is just boop, tell it, hey, take your ng zone and make it a no op. No operation there. Now you'll notice back in the browser here, on load, and I'll refresh that just so you can see I'm not cheating. On load, we get two change detectors run instead of 4, just 2. And you'll notice now if I come in here and I click mutate, nothing. I'm clicking and nothing is happening. I can click start animate and I get a bunch of ticks logging out just to prove that the animation frame is happening, but Angular, meanwhile, is saying, hey, I'm not going to mess with your performance. I'm going to stay here until you tell us otherwise. So let's tell Angular otherwise just so we can actually make this work. And we'll go into our app component and we'll say, hey, Angular, detect changes. So this CDR business here is just pretty much the only close to fancy thing we've done here is just said, hey, Angular, give us a reference to your change detector and put it on our class so we can use it. And we've called it CDR for change detector ref, which is, well, could be worse as far as names go. And let's grab that other one too, uncomment it, save it, and flip back to our app. Now, you'll notice I can click mutate and OS X is upset at me, but once OS X sort of calmed down there, we see that I've got one thing has happened, one more change detection has happened. I click mutate again, 1 change detection, 1 thing. So we've made a little bit of savings, and again, in 9.9% of apps, or 99% of apps, this is not going to be the deal maker anymore. Even on mobile, Angular is snappy. But this can be handy again, because if we hit that start animation, you'll notice the change detector's firing less aggressively. We get that tick, it's still logging out just to prove that it's ticking, but the CD is happening like every 4 frames. And the reason that the CD is still happening is that eventually we do want things to update. We just don't need our frame count to update at 60 FPS. We can let Angular redraw at a much lower rate. So we've basically said here, hey, if the animation frame count is divisible by 20, throw something out there. So what is that? I think, I'm not great at math, but that might be like every 200 milliseconds it's going to log something out. Sure, somebody wants to correct me? No? Okay, everybody was all over the commas before, but not the math. That's good. So it's like I'm talking to my people here. We can just hand wave the math away. All right, so let's get out of the weeds again. We've looked at why we might want to zone out. And as we saw there are risks to zoning out. If we turn zone off, we can get into situations where our app doesn't actually update. So we want to be a little bit more careful about turning zone off. Only want to do it in certain cases. So there's really only 2 cases that I could think of where I would want to disable zone in Angular. And one is in like an ultra high performance app with lots of asynchronous updates, something using request animation frame, things that are doing lots of real-time updates from some sort of socket connection. That first class of application is a great candidate for turning zone off in Angular, because you can just tell Angular, hey, update now. You're getting your updates from somewhere else on a regular interval. We can do this a different way. And the second class of application is actually broader. I know I said 99% of apps probably don't need this, but if you are using a state management service like RxJS or Redux, you probably don't need Zone.js, because your app is updating whenever your store updates. So really all you got to do is say, hey, if the store updates, fire a change detector ref, and that's it. We don't need Zone.js. You could just do that, and it would work out of the box. How would that work? For a dumb component? Well, okay, so okay, so we got a question. It's ad hoc, and it's about how would change detection work in an async? How will Angular work if it's not being told to update its changes via zone with a dumb component with an async pipe? Did I get all of that? Okay. I think I can actually answer that question with an example if you give me a minute to get through the next bit. I have a really ugly demo, but I think I do that in there, and it might be worth exploring. So if you don't mind, I'm going to put that question on hold for a second, but I will get back to it before the end of this. And actually, the time is right now, because the next slide over is the resources slide, which has the links to things I did for this. So I actually have a slightly complicated example here. And I say slightly complicated because it's super complicated. When I started pitching the idea for talking at a meetup, I was told that I should come up with an exciting demo, and I really failed miserably to do that. Well, all right, I have something here that shows you things animating. Not very nice things. You might get a sense that I'm one of those back-end people who just happens to work for a front-end company. I won't show you the UI part. It's hideous, but this is some hackery I've been doing in my free time. It involves no Zone.js. It involves Angular. Let me just make sure it's in Angular mode. Perfect. It involves Angular, and there's an async pipe in here. So I've got, if I open this little hideous window here, you can see if I move over, I've hidden the UI, but if I hit the arrows there, it should actually update the translation positions here. And I might need to move over a little bit more radically to see that actually update. You can see the 435 has changed there. We give a touch more real estate so that you can see the vectors. Anyway, this particular example, again, this is a WebGL app The UI here is actually Angular. I know it's hideous, but we'll take a look at how it's not using Zone in a second. And there are literally, I want to say thousands plural, but there's only 1,000 and change little. Now, they're supposed to be sedans, but I'm not a 3D artist. Just let's take a peek at some of the code, though, and see if we can answer this question about the async pipes. So I've got another file over here. This is the exact code I want, and let's take a dive into that Angular code, see what we see. So before we even get into the Angular, I'm just going to start right out of the box and open the package.json and zoom in a bit. And I'm going to Control F for Zone. So there is no Zone.js involved here at all. And this might cause you a problem routing. So if you're ever trying to like completely exclude Zone from your project, you're probably going to need to keep it in if you want to use the Angular router. In this particular project, I didn't keep it in because I really just wanted to see if it worked without Zone, and I didn't actually get an error. Now that I'm saying this out loud, I feel like under the hood, I maybe did a yarn install and then never like cleaned up or something, and Zone's secretly lurking back there. But regardless, let's dive into the Angular code. All right, there's all sorts of cruft in here. This is a large code base, and if we look at the Angular bit, this is a bit more simple than an actual Angular CLI app, but down here you can see that I've said, hey, ng-zone, you're going to be a no-op. No Angular zone, and let's take a look at our input component, or camera component. I think this is where I used the async pipe. No, I lied. It's in the app component. All right, there it is. I knew I had an example. I'm so glad you asked this question because there it is. So we have our input description observable. And basically what this Angular app does, is aside from all that 3D ugliness that's rendering around there, basically the 3D program exposes the parameters for its camera, its software, and other things that it's doing in the background, which are a lot and varied, and we'll talk about that another time, but it basically exposes them to Angular and says, hey, here's an object. And Angular can't really update that by itself. In fact, this app, all the UI stuff in this app is actually streaming through Redux. And you won't see a lot of actions firing because the renderer itself isn't tapped into the Redux, but the UI components are. And if I flip back to the code, we see this async pipe here. So we're actually getting the input descriptions as an object. So if I say, I'm selecting the inputs. So this is actually a Redux application, and I've used this @select decorator, which is basically just a shortcut for saying, hey, let's take the store and subscribe to it, and then grab the inputs property out of it. So really, that's all this select business does here. It's a nice little shortcut that you get with ng Redux. I mean, you can do this with RxJS as well. Same difference. So this is an observable of input description dictionary, which is a big mouthful, but it does actually pass through the async pipe, and updates do, in fact, happen to the code. Like if I come over here, even though there's this insanity, if I hold down on the left arrow, you can see the bottom thing updating. So even without the Zone.js, the reason this actually works, and it's the secret sauce piece that I'm skipping over, the reason this works is somewhere I'm actually subscribing to the store. And I haven't set this up in a while, so I'm just going to look for a subscribe call. Oh, never mind. Thanks, Mark. Apparently I'm more flustered than I thought. In my ng on init here, I've got this store subscription that I'm registering, and I'm saying, hey, store, subscribe, and when it happens, detect changes. So there's only one spot in the app where I'm actually calling the change detection manually, and it's on init in the actual app component. So that is a way you could use the async pipe, get changes to actually register because they're happening, like Angular is being told to update when you actually know your state is updated, and then Angular does the update. Like if I comment this line out, and I come back to our app, we'll be back to hideousness again. Well, oops. Or maybe it's not even going to live demos and all that. It says it compiled. If I update this, I don't think it's going to keep in. Oh, Maybe I didn't trigger a save there. No, I didn't. Okay, that's why. Failed to save. So if I comment out that one line, and if this eventually reloads, oh, I commented out that line and I ended up just bricking everything. So I actually, apparently I've written some code that, oh, it's not even that I've written code, it's that I have TypeScript cranked up. TypeScript's now angry because I'm not using the change detector reference. So maybe I can just, make a null statement like there. So I'm not invoking the function now, I'm just trying to make a demo, which is, all right, let's see if this change detector fails to update. Now, oh, it's still updating. All right, I can't even break my own app. Like usually in these demos, you're supposed to go the other way. It's not supposed to work, but apparently done something different there. I swear there's no Zone.js in there. It's cheating. But anyway, the reason I wanted to look at this particular renderer, or any renderer really, is that request animation frame, as we saw in the previous example, it fires as fast as it possibly can, which is generally going to be synchronized, I think, with your monitor or with the browser's intelligence or something, and it's going to update all of the time. And we've got 1,000 different, well, it's not fair to call them sedans, but we've got these sedan-like things moving around and doing their own business. And part of the reason it's relatively smooth is that there's no textures, part is that there's no Zone.js triggering the change detector all the time, and part is that a lot of the logic has actually been offloaded to the GPU, which is a fun conversation for a whole other talk. So anyway, that was zoning out. We should hopefully have a basic idea of what is Zone.js at this point and how it's used in Angular and how you can turn it off if you actually need to, which is probably not going to be often. Now, there's at least one question already, so I'm going to just dive right into that. First question.
Is that demo that you showed us
Yeah.
better suited to using Zone.js or just native Angular?
It would be better just to use like a native Angular, or inside of Angular, one thing that I wanted to talk about but didn't was that you can essentially say, hey, Angular, give me ngZone. And this ngZone object that you can bring in, it's really handy in the odd case where you want to run one thing outside of Angular but not necessarily your whole app. Like maybe you want your app to depend on using Zone and being magical, and then every once in a while you want to say, hey, run something outside of Zone. So if I have, let me just add one more thing here. So private zone ngZone, and we can say, zone.run outside Angular, and give it a function and say, and you can run anything you want outside of Angular, but it won't actually update Angular. And I don't have a good property to actually demonstrate that in out of the box, but basically Angular has a built-in mechanism that will let you run selectively things outside of Zone. And this little bit here is something that is really handy if you need to tap into like a mouse movement or that scroll thing, because it'll let you execute all those functions and not update Angular's change detector. So really, in most cases, you're going to want to stick to Zone. But in that particular app, because of all the request animation frames and because of the architecture and because it's one of the nice edge cases where you don't need Zone. Sorry, there was a question right there.
I've seen a lot of like Stack Overflow places where they do like change detection with the ngZone. Is that like, why is that really? I know at the end it's just a tick if you go into the.
Mm-hmm.
So like, is that preferred, or is it just you just get application ref and just?
Okay, so if I've understood that question right, basically you've seen Stack Overflow posts and blogs or whatever where people are like, hey, we're going to use the change detector to do our change detection manually, and you want to know reasons. Is that the gist? Okay.
Yes.
So reasons in that case are, hopefully you have some edge case reason, because in 9 out of 10 apps, there's no need to do the bells and whistles. Really, what I found in the last 2 odd years of like seriously using Angular greater than 2 is you want to find a good subset of the platform that works for you, and you want to stick to that on your app. And going sort of out of the park with these kind of crazy features like Zone.js, unless you have a really good reason, don't do it, basically. And a good reason might be something super intensive, but let your app break down before you try and take Zone out. Oh, sorry.
And I'll go over there.
All right, we're going over to the back corner there.
Yeah, hi. So I was thinking some of the examples that I have seen are the other way around, where we keep Zone.js turned on, and then the components that have crazy use of the ticks, we turn off change detection for those components. What do you say about that?
Okay, so are you specifically talking about, say, changing the change detector, kind of like, say you were up here and you said something like change detector, wait, which one of these is it? It's neither of these. Something like, you can say change detection strategy, I think. I don't know why TypeScript isn't being happy with me, but you can bring in a change detector strategy and say on push, basically. And I'll just fill that in sort of pseudocode. So the on push strategy, I think, are you referring to the Minesweeper demo where you've seen the person make Minesweeper and they were like, oh, Minesweeper was really not performant, and then we re-architected it to use our components this way and now it's better? That kind of? Okay, so this is a very valid strategy. It's less heavy-handed than eliminating zone. It works for a wide variety of cases. There's nothing wrong with on push. I tend to recommend on push in many, many cases because if you're using something like NGRX or Redux, it's really easy to work with on push and not have issues. I mean, it really comes down to your app, your team. Like every application does to most extents, but on push is, I'd say overall, like if you've had an app that's been around for a while, it's a less expensive way to do that. If you're starting greenfield, I mean, there's nothing stopping you from not using Zone and just not using it. But if you took an existing app and were to take out Zone, you'd probably, unless you were really strict about your reactive design or whatever, you'd probably run into some cases where it broke the change detector. I think that kind of ties back into the very first question about the on push, or not the on push, but about the async pipe and how that would work with Zone.js disabled. Yes.
I may be way off here, but I'm enamored with WebAssembly, and I would like to ask you a question about the tripod or triad of Angular, WebAssembly, and Zone.js.
Wow, okay, so WebAssembly, Angular, and Zone.js, is there, like, just in general, or was there a specific thing you wanted to know about those things?
Well, in general.
Okay.
I'm interested in your thoughts.
Okay, well, in general, I mean, I would actually kind of think back to Hussein's talk from just before this about WebAssembly. Like WebAssembly, to me, a lot of what WebAssembly means is the ability to ship code to the browser that doesn't have to be parsed. So I kind of look at it in that sort of space. I don't think about it as necessarily competing or separate. It's another tool we're about to have in our tool belts that's going to let us move more code to the browser. And the reason I reference Hussein's talk is that if you had code that were, say you had, backing up for a second, your JavaScript code is going to be written in strings. Strings are going to be long. They're likely going to be encoded in a format like UTF-8, which means you're going to have a number of bytes for each character you want to represent. All that's got to come down to the browser. It's got to be parsed, evaluated, run, so on and so forth. Where WebAssembly really wins is being able to say, hey, let's not take that code. Let's actually take bytecode, so binary instructions essentially of what we want that program to do. So the idea of taking Angular and making its libraries, the actual @Angular/core, @Angular/platform, and making those WebAssembly distributables, I'm kind of interested in that a lot. I think that could be a big win, and it should help make Angular a leaner app to deploy, faster to start up, lots of wonderful things. But I see it as a sort of a separate thing to Zone.js itself. Zone is more or less a convenient way of tapping into the asynchronous event loop that's going on in the browser anyway. Weird thing is when Zone was first announced, or not even when Zone was first announced, when Angular 1 came out, I actually thought they were using something like Zone under the hood, because this kind of an idea has been floating around the community for quite some time. This whole tapping into your set timeouts and your @event listeners and everything. There's been discussions on Firefox message boards even where like Dominic, the author of the Q library, is talking to Firefox devs and being like, why don't you have set immediate? It's the best. You should use this. And they're like, well, why don't you write your own event handler and then your app can reason better about what asynchronous things it has to do or doesn't do. So when Angular itself is leveraging Zone, it's more organizing that asynchronous flow. And it's kind of, in my mind, a little bit separate than the WebAssembly issue. And the third thing, sorry, what was the third thing you mentioned in there? There was Zone, Angular, WebAssembler, just those three? I think that could be like pretty special. I'm excited about WebAssembler in general just because it's a new thing you can do with the web, more options for, say, like LLVM to take C code and translate it into WebAssembler, but I'm actually kind of less excited about that at the moment than I am just pushing code to the GPU. And that might just be my own bias where I love parallelization, and GPUs are great at parallelization, so that's sort of where I come in. But I know you didn't really have a specific ask, but that's just sort of my 30-second ramblings about the triad of Angular and Zone and WebAssembler. I mean, I think you could just have the duo of Angular and WebAssembler, or just Zone built into the library and whatever.
Specifically looking for the best case to demo.
The best case to demo all of those things. I think if you wanted to demonstrate the benefits of it, specifically WebAssembler, you might start by like demoing the initial payload side of an app. So if you looked at, just going to escape this and take a peek at the network requests that this particular app makes. Memory network. So for me, the place where I would demo that would be looking at the network requests. So you can see, just to run this 3D stuff, I haven't used, outside of front-end frameworks, there's next to no libraries involved here. And apparently I am too zoomed in to split this out. So I got to zoom out a little bit. And you can see my vendor bundle 6K. My main bundle is a whopping 1 megabyte. I am running in dev mode, so that's why it's not minified or anything. That's just the main code. The UI code I have now here is 581 kilobytes, which is substantial for UI code. And then I have, in this case, actually let me just flip over to Angular mode. And then I download a giant dev Angular bundle. And again, this is dev mode, totally unoptimized, but my Angular bundle comes in here at 6.5 megabytes, which is a lot of JavaScript code to be shipping to a browser. And again, in production, it wouldn't be shipped that way. It would be all minified. But getting back around to your question, the place I would demo it is with WebAssembler, you would be shipping probably something smaller than the gzipped version of the smallest version of the Angular library that you could ship out there. So we're going to be talking about things on the order of hopefully tens or less than tens of kilobytes, as opposed to somewhere up in the order of megabytes. That's what I would demo first, just with the marriage of WebAssembler and any front-end framework, but Angular as well. Hope that answers that question a bit. Oh, back over here, yes? Oh, that's a good question. So I think it was Angular elements, and if it's with Zone or not with Zone, I don't know the answer to that off the top of my head. I'm sorry. I feel kind of bad that I'm not more prepared for that. Wow, look at this horrible artwork. Any other questions before we? Okay, well, I'll be up here for a little while. It is a meetup, and feel free to come and chat. And shout out to Hussein for his wonderful Progressive Web Apps presentation. Thank you. I enjoyed that, and thanks for coming out.
So thank you very much for joining us. It was a pleasure to host you here. If you might know, this was the first meetup that we've had in our new office. If any of you have any questions about Rangle.io, then we have some of the folks over there. I'll be around. If you have any questions for our speakers, I believe that they're still both here. Well, Michael's obviously here.
I'm on vacation. I'm here.
I don't know if Hussein's still around. So we are going to have hopefully another Angular meetup without as long of a delay as last time. And additionally, much as we love Angular, there's some other frameworks we've heard of. And in particular, 2 weeks from now, we will have a Vue meetup in this office. So if you're interested, look us up on Meetup and join us for the Vue meetup in 2 weeks from now. Yeah? Sorry? Oh, if you just go into meetup.com and type Vue, you will find it. It's very easy. If you just Google for Toronto Vue Meetup, you'll find it also. Cool. Thank you very much for joining us. And if you guys want to hang around for a bit networking, feel free to do so. Thanks.
Every time you two are getting rough, my mind just sounds like Shia LaBeouf. It says no, 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 just no, 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 no. And every time I see him with you, my heart sounds like Shia LaBeouf too. No, 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 no. Trying